We'll see. Oh yeah, we were having this trouble last time, weren't we? So let's talk for documents. There we go. Now, can we all listen, please? So, listen. Thank you. I think the plan is for next week to have the maths test on Thursday at 10 and the physics test on Friday at 9 in class. Okay? So, please bring your laptop for the class at 10. Why do you look shocked? I told you this morning. No, you weren't in the class this morning, that's right. Engineering students, sorry Sean, you don't know this. Engineering students, the maths test, you need your laptop because it's an online test. Oh yeah, you don't know either. So, I'm giving you, business students. Yeah, no, I told the business students, didn't I? Yeah, I didn't tell you guys. So, the business students know this already. I'm going to give you a list of the topics you need to study for the test. Okay? So you want to write this down. Yeah, this is for the test next week. Yeah, what you will need to study. Okay? Oh, no problem, Jerry. No problem. Happy to help. Now, write that down carefully, okay? Yeah. Oh, sorry. Everything in math class, of course. You don't need to study for the other subjects, just for math is all I care about. Go on, do. Tell her I said that. So, what the test will look like, guys, is you'll have 20 short questions. Okay, so for example, I said something like to the business students, the roots of x cubed minus 5x plus 6 are 2 and blank. So you have to type in the right answer here. So you type in 3. Yeah. So you'll have 20 questions like this. Huh? 45 minutes test. Yeah, I'll give you paper. And I want you to write it down and then put the answer in. Yeah.
The
questions online, yeah. Yeah.
I'm sure you missed something that's not everything.
Yeah. No, I'm doing this because will be the quickest way to give you feedback on how you're doing. This test is worth 0%. You're doing this test yourself how you're doing in maths. Okay? Alright, so we'll continue now. So we're looking at next now rules of logs. So we need to look at this thing called a log now, which we've mentioned a little bit before. Okay. You have that? So, when I write something like this, log bx, this part is called the base, And this part here is called the argument. And what is the meaning of it? So, okay, Sean, you tell us. No, you changed your mind?
You can do it.
Yeah. Okay, Jerry, do you know what this means?
Yes. Log, use 3 to add.
Yeah. What's the answer? Why 2?
3 squared.
Yeah. So when you write something like log 3 power 9 equals what? That's the same thing as this. Saying 3 to what power makes 9? Yeah, so the answer is obviously a 2. So the idea behind logs bx, you say b to what power? Yeah, it becomes x then. This is the idea here. So let's have a look, just some simple examples. Log 10 1000. 3. Log 2 8. 3. Let's make this a little bit harder. Let's say something like log 201. 0. Yeah. Yeah? What's wrong? You don't look happy.
Why?
Why this? Yeah, because 200 power 0 equals 1. Which rule was this? This was rule 5 or something like this? Yeah. Yeah. Okay, so just like with the powers, we also have rules with the logs. We have about 6 rules as well. So let's have a look at the 6 rules. Can I scroll down? I see people writing still. What's wrong? Convert? We're going to do 2 converting rules. You mean like changing the base? Yeah, we're going to do 2 rules. Okay, continue?
Yeah.
Alright, so let's have a look now at our 6 or so rules of log. So the first rule of log says that log base b of x multiply y equals log bx plus log by. Yeah? This is the most important, most useful rule about logs. In fact, this is the reason logs are so important. Because logs are able to change a multiplication into an addition, a plus. Okay, so this is the most important rule for logs. You should never forget this rule. Most important rule. This is like Pythagoras' theorem for logs. It's like the basic, most important rule. Okay? Really, really important. Let's look at the proof of this. Again, just like with the powers, the proofs are short. So the way to prove this, you say, let the x equal b to some power, and let the y equal to b to some power. So this means log b xy will equal log b bn bn, which equals log b n plus n. Now if you think about it, b to what power makes b power n plus n? N plus m. But I could write n like this. How do I find the n here? N is log bx, because b to what power makes x? B to the power of n makes x. So I can change the n into log bx, and the m log by. So I have proven the first rule here. Please write this down. Yeah. Okay. Have you got that?
Yeah.
Second rule. Second rule. Rule 2. Log x divided by y is equal to log x minus log y. Yeah? So similar. Let's look at the proof. Let x equal bn, y equal bm. Log x divide y equals log bn over bm, which is log bb n minus m, which is n minus m, which is log x minus log y. Nearly the same as the first rule. I'd like you to write this down. That's the second rule. Yeah. Can I scroll down? Yeah, no problem. No problem. Continue? Okay. Rule 3. Rule 3 says log bxn is equal to n log bx. In other words, you can bring powers down in the front. Let's look at the proof. Log bxn equals log b x n times. By using rule 1, you can change this into log bx plus log bx. Stick to English now, Sean. Okay? Shay. Plus. How many of these do I have? N. So that ends the proof of the third rule. So write this one down. This is rule 3. Say again? Do you mean brackets here? Here. No rule. It's only if it's on the x and not the log x. continue?
1 minute.
Okay. Yes? Okay, continue? Yeah, right. Fourth rule. Log xy equals 1 over log yx. Sleepy, Bruce? Up all night doing maths? Or physics? Chemistry? That's no good for me. I only care about maths and physics. Chemistry homework or chemistry revision? What? Okay, let's have a look at the proof now. I always forget this proof. What should I do? Proof. Google. No. Let's see. The reason I get confused is I always have two ideas on what to do. I always think about either I make x equals bn and y equals bm, or I think it is this. So I'm going to say let x equal bn and y equal bm. Yeah, no, this is it. I remember. So log xy equals log bn bm. Now very carefully, what is the answer here? B power n to what power makes b power m? M over n. Because if you think about it, bn to the power of m over n makes b power m. So this one is m over n. Yeah? That's equal to 1 over n over m. Why? Why not? Because 1 over, for example, 1 over 2 over 3 is 3 over 2. It's the reciprocal of a reciprocal. Double flip. Okay, so these two are the same thing. So this, you can say, is 1 over log b m bn. Yeah, because this is the same as n over m. B power m to power n over m is b power m. Which is 1 over log yx. Yeah? Yeah? I still see people writing. Continue? Right. Rule 5. Change of base rule. So this is when you have base B, but you would like to change it to a different base, like base C. So if you change the base from a B to a C, the price you pay for using base C is you must divide this now by log CB. This is the price you pay for changing a B to a C in the base. Proof. Think. Again, this one confuses me too. I need to say let. I think B equals Cn and X equals Cm. I don't know if this will work. I guess we'll find out. Let's see. So this is log Bx, which is log Cn Cm, which is m over n, which is log Cx over log CB. Hey, it worked. Super. Okay, so we've proven this rule now. There's the fifth rule. Okay, got that proof? Rule 6 isn't really a rule, it's just some facts. So, first one is log B1, this is a 0. Okay. And log Bx is undefined if x is less than or equal to 0. We don't like to use minus values inside of log. It's not something we do. It's not really it can sometimes be a problem and sometimes not. I'll give you an example. What's log 2 4? This is equal to 2. But you can also say log 2 4 is equal to log 2 minus 2 multiply minus 2. I mean, that's the same as 4, isn't it? And then using the first rule of logs, you can say this is log 2 minus 2 plus log 2 minus 2. So it looks like we have problems here, but actually if we simplify it, we don't have a problem. So sometimes this is okay and sometimes not, but we try not to have a negative here, okay? We try to keep it positive. Alright, let's have a look at some examples now where we use these rules. If I can just borrow the book there, please. Thank you. Oops. Okay, can I scroll down? These are all pretty easy to start with today. So, first example, calculate log 7 7. 1. Okay. Next one. simplify this? Well, what rule is this now? The second rule, which says this, which is log a tree. Yeah? Okay, next example. Can I scroll here? Yeah. Next one, we want to simplify this. Okay. No, that's a bit too easy. Let's change it a little bit. Six. I'll go with something near 6. 1,024. Well, near enough when you consider the numbers go from plus and minus infinity. Okay. So let's simplify this. I think what I'll do first, if you wanted to, Jerry, Bruce, if you wanted to, you can simplify this a little bit. You can bring the 2 up here, so you get log 2 16 plus log 2 8 minus log 2 1024. And then because you add, what do you do to the 16 and the 8? You multiply them. And then when you minus, divide. Now, hang on, don't tell me. Two, 4, 8, 16, 4, 3, 7, 2, 4, 8, 16, 32, 16, 128. 1 over 8. 1 over 8?
Yeah.
Which is log 2 minus 3. 1 over 8 is 2 minus 3, 2 power minus 3. So, 2 to what power makes 2 minus 3? Minus 3 is the answer here. What's wrong, Sean? You don't like this? You don't like it? You don't like the way I did it, or you don't like this?
I don't have the way.
Ah, you don't like me then?
The way.
Okay, I know. No, there's many ways to do it. Many ways to do it. Continue?
Yeah.
Okay. Oh, you don't have? No, that's okay. What's going on there? Too much sugar. Yeah, okay, yeah. I'll help you. I'm planning to go to the gym.
You can plan together.
No, I'll go myself. I'm going to go there, I'm going to pay a lot of money, and I'm going to walk for an hour. €29 for walking. Wow. I could get like 4 taxis to the city centre for that. If I could walk, yeah. Oh wait, I forgot, I don't have any money. This is going to affect my plan. Okay. Not necessary, thank you. Okay, next example now. Last time we saw this e, which you remember its value. So what we're going to look at is log with the base e, yeah. And this actually is written a special way in maths. It's written like this, ln x. And that means log base e. So for example, ln 2.718 should roughly equal 1. 1. Yeah. Log 1 should equal 0. I don't know. 8.2 or something is about 2. Or so, I don't know. What is actually, you tell them using your calculator, what is log 8.2? ln 8.2. Well, there's a button on the calculator that's called ln, funny enough. 2.1? I was close. 3? No. Oh wait, now please, guys, this is important. Sean, Lee, KJ, this is important. There is 2 buttons on your calculator. This one and this one. Okay, this is log base 10 and this is log base e. You can test it because if you type in log 100, you should get 2. If you type in ln 100, what do you get? You got it? Yeah.
Yeah, 3.47.
Don't listen to him. What's 3.47?
Now forget it.
Yeah, okay. What's happened? Okay. Now, next, we want to have a look at the graph of log x. So, Lee, Chu, be good, please. Thank you. Okay, we have 2 graphs we want to look at. If the A is positive or if the A is negative. In this case, it will look like this. And what is this value? Okay, yeah. 1 is enough for me, yeah. And this graph is just upside down. 1. Here. Because it crosses the x-axis when x is 1, because log 1 makes the 0 for y. The root is at 1, because only 1 makes the 0. And you might be wondering, well, what about if I had a b here? The b has the effect of moving the graph up or down. Because remember, log bx equals log b plus log x. So having a b here is just like having an extra number at the end, which just really moves the graph up or down. That's all that has happened. But it still has the same shape. It just moves it up or down. That's all that's happened. So in the exam, they don't usually care about that, so we don't need to worry so much about that. Okay. Let's have a look at some questions to do now. Okay, try these now, please. Oh, I should just give you a little bit of English for those people who need some vocabulary here. How do you say this? You have many ways to say this. X power y, x to y, x raised by y. Yeah, I think these are the main ones. Will you use what? I don't like you using the dictionary. It's bad for you. Could you what? Oh no, no dictionary for the exam.